So now that we know how to construct a confidence interval and run a hypothesis test, I want to talk a little bit more about the margin of error. The margin of error is useful because when we run studies, oftentimes we want to know beforehand how many people we need to examine in order to get some statistically significant relationship. Think about it from the doctor's perspective. How many people do you need to treat with a drug before you're convinced that the drug actually works? That's what we're trying to figure out. If we want to know the margin of error beforehand, we can figure out how many people we actually need to survey. So let's go back to our hot dog example. Let's say we want a margin of error of 5 milligrams of sodium. That means we're reaching up 5 milligrams and down 5 milligrams for a total range of 10 milligrams. And we want to do this with a 95% confidence interval. The question then becomes, how many hot dogs do we need to test their sodium level for in order to construct this level of confidence? The way we can think about this is through the formula for the margin of error. This again is what we reach up and down. So we want that to be exactly 5 milligrams. Our critical T depends upon our degrees of freedom, and since we don't know how many people we're going to sample, we're just going to assume we're going to sample a very, very large number. So that will be approximately close. So we'll use the critical Z for a 95% confidence interval. That would be 1.96. Our sample standard deviation is 31. And if you don't remember that, you can go back and look at the last video. But this is given to us in the problem. The last thing we need then is the sample size, and that's actually what we're solving for. So the last thing we need to do is just rewrite this in terms of the sample size, and we can do that using basic algebra and basic arithmetic. So then, to solve for n, we want to get it by itself. So I've moved it to the left-hand side and the 5 to the right-hand side, which gives me this formula. We can then solve for n by itself by just squaring both sides. Once we calculate this out, we get 148. So approximately, we should sample 148 hot dogs. And I say approximately because remember, we used the normal distribution rather than the t-distribution to figure out what our critical value should be. So this is approximately how many people we should survey, or how many hot dogs we should survey, and that will give us a margin of error that's pretty close to 5 milligrams. So that is the confidence interval for one sample t interval. And again, this is the margin of error that we just discussed. In the next set of videos, I'm going to go over testing for the differences between two means. That is, if we have two groups of things, let's say black people or white people, or regular hot dogs versus low sodium hot dogs, we could test to see if there's a statistically significant difference between those two groups.